Thank you very much. So as just mentioned there, unfortunately Sean Lyons can't be with us today. It's a very busy week for people in the energy sector this week, but also for economists because the Irish Economic Association is clashing today. So hopefully what I plan on doing is giving a quick overview of the markets and regulations strand, which is led by Sean Lyons. And hopefully I'll do it justice. I'll present two of the papers in that strand and then move on to the policy and social studies strand, which is the strand in which I'm leading. So the people involved in this markets and regulations strand, we've one postdoc, one PhD student, and a number of research assistants and interns. And then we've a lot of associated researchers, both in Trinity, the ESRI, and here in UCD as well. The main focus of the research within this strand is on market design and evolution, issues in performance and incentives. So how do we incentivize different generators to enter the market? What happens to prices within the market when we introduce lots of renewables? Looking at different support mechanisms for renewables going forward, and issues surrounding regulatory control and governance. So looking at market design issues and intervention in the market by the regulator and how that might look going forward under the EU target model. So we have 24 ongoing pieces of work within this particular strand. So obviously I don't have time to go into each of those, but what will be available outside later on today is just a short handout giving an overview of all of those papers. So if anybody is interested in reading a bit more about those pieces of work, they can contact either myself or Sean, and we can provide you with those individual papers. So what I'm going to do now is just give you an overview of two of the most recent papers within this strand. So the first one was prepared within the Economic and Social Research Institute, and it looks at incentives for thermal generators entering the Irish market in the presence of wind generation. So it looked at a number of scenarios with future wind and modelled this econometrically. So I guess a lot of the engineering models in this space would use models such as Wilmar or Plexus, very complicated, sophisticated unit commitment models. In the economic space, we're trying to generate kind of parallel models, but using economics techniques such as econometrics that are perhaps a bit more user-friendly for policymakers and certainly a lot quicker to run. So this is an econometric study, but is validated against the actual results of the SEM over the past 3 years. So it looks at three different scenarios, estimating conventional generated revenues under each of those. So looking at no wind output as in the past 3 years, and then a high wind output scenario where we're looking at 3,000 megawatts of installed wind by 2014. And estimating conventional generator revenues under each of those three scenarios. So the main ways in which wind impacts on conventional generator revenues is potentially by lowering the shadow price in the market, by increasing costs of conventional generators through increased cyclical activity, either through increased startups and shutdowns or more ramping activity, and then a lower utilisation rate of conventional generators. So they'll be required to operate less often, therefore reducing the potential to be online and earn revenues in that way. As part of the study, uplift and capacity payments were considered, but I guess the main focus of this work was on the shadow price element. So the assumptions for the uplift and capacity payments are based on what the situation was over the past 3 to 4 years. So uplift as an average and capacity payments for each unit as an average as they were in 2008 to 2011. And the real interest rate of 2%. So the results of this particular study show that maybe contrary to what we were expecting was that, a lot of the engineering studies show us that increased variable generation on the system creates an increased demand for flexibility. But what these models are showing is that actually the non-flexible plants are being utilised more because the flexible plants are able to turn off. They're the ones that are being turned off. So they're the ones that are being affected more. So there's actually a benefit to being not flexible in the Irish market. And being not flexible means you get kept on and you get to your revenues aren't impacted as much. So what we found, or what was found in this study, was that the coal units were cycled less frequently than the CCGT units, so they were left to operate for longer than the CCGT units. And there was an increase in cost for the CCGT units, which was greater than that for the coal units. And in terms of net profits, these are profits for a 3-year period in euro per megawatt installed. So we can see here for the gas units, coal units and the distillate units, the baseline is wind as it was in the last 3 years, and the 3,000 megawatt scenario is with 3,000 megawatts of wind. So we can see that there's a reduction in profits for both the gas and the coal units, but the gas units are impacted more than the coal units. Because they're more flexible, they ended up being shut down and started up more often, and they had a relatively lower utilisation rate because of their inherent flexibility. However, I guess the magnitude of the difference is perhaps less than some commentators may suggest when we're looking at a system with high penetrations of wind. So a reduction of between 1% and 2% in profits over a 3-year period. And you can see that the profits of the gas units remain significantly higher than that of the coal units. So by looking at these figures, it would suggest that the incentives are within the market to invest in gas units over coal units for 2014. And there was no significant change for the distillate units. So that was the first of the studies I wanted to present within this strand. And the second is looking at CO2 emissions within the Irish electricity market. So again, using an econometric simulation study. And what this study looks at is comparing demand and supply measures for reducing CO2 emissions. So comparing an increase in wind generation with a reduction in demand to see the associated CO2 emission savings that you can get with each. And this was conducted by a PhD student called Amy O'Mahony, who was a poster outside, and also in conjunction with Ben Hobbs in Johns Hopkins University in the United States. So the results of this particular study show that a 1 megawatt reduction in demand per hour on average reduces CO2 emissions by 0.6 tonnes per hour, so a reduction of 0.6 tonnes of CO2 per hour from a 1 megawatt reduction in demand. And comparing that to a 1 megawatt increase in wind, we see a reduction of 0.4 tonnes of CO2 per hour. So what this essentially implies is that supply and demand measures are not equally effective in terms of reducing CO2 emissions, and that wind generation is 33% less effective in terms of CO2 reduction than a demand side measure. I guess a somewhat back of the envelope calculation to see how this stacks up in money terms. So based on the smart metering trial, it was estimated that smart meters cost approximately €220 per house per meter installed. So if we're looking at all households, installing a meter in all households in Ireland, that would equate to approximately €322 million. So for that same €322 million, how much wind generation could we install? Well, according to SEAI cost estimates, we could install approximately 200 megawatts of wind generation for the same amount of money. And with a load factor of 29%, that equates to about 508,000 megawatt hours per year. Okay, so to get the same energy saving, so that's output from the wind of 508,000 megawatts hours per year. To get a similar saving from the smart meters, that would equate to approximately a 2% average load reduction for the households across the country. And the smart meter trial showed an average of a 2.5% reduction. So it suggests that, smart meters are perhaps a more effective way of reducing CO2 emissions than wind generation. However, of course, there's other benefits to wind generation that aren't considered here. We're just looking at the CO2 emissions. Plus, the potential savings from CO2 emission or from a smart meter are of course dependent on human behaviour, and there's studies being conducted on the effectiveness of smart meters over a longer time horizon. So perhaps when they're first installed, people are very responsive to them, but once they've been installed for quite a long time, then the response tends to diminish. However, with a wind farm, once it's installed, you know, you're pretty much guaranteed an average CO2 savings per annum based on load factor ranges. So I guess it's this human behaviour side of things that's been looked at in the other economic strand, which I'm going to get on to now in a second. So some other papers in this strand that we're looking at are on interconnection. So interconnection not only between Ireland and the UK or Ireland and France, but also across Europe in general. So looking at interconnection projects between the UK and the Netherlands, UK and France, and wider afield. We're doing some work on retail customers and pricing within the smart metering side of things in this strand. Also looking at the impact of UK carbon pricing on the Irish market, so in particular the recently introduced UK carbon price floor. So what impact is that going to have on trading across the interconnectors and as a result the price in the Irish electricity market. And then more specific Irish related studies looking at the timing of replacement of some of the units, looking at emissions from the market, governance and market design within the SEM, and the potential export of wind from the Irish system. So that's the markets and regulations strand, led by Sean Lyons. And the second economic strand that we have within this group is on policy and social studies. So we have 3 postdocs within this strand and 4 PhD students, and also a number of associated researchers in the ESRI and here in UCD. And the main focus of the research within this strand is on consumer behaviour and the sort of pricing signals that retail and domestic customers need in order to incentivise certain behaviour actions. Looking at social acceptability issues and valuing externalities such as visual impact of renewable technologies and so on. Estimating people's willingness to pay for electric vehicles, for certain characteristics of electric vehicles and for energy efficiency measures and so on. And looking at some of the wider societal benefits of promoting renewable energy. So within this strand we have 18 ongoing pieces of research work. So I'm going to give you a very quick overview of 2. And then one of my PhD students, James Carroll, is going to go into a little bit more in depth about one of the projects that's been undertaken with a large Irish electrical retailer. And then Gary O'Callaghan from Siemens is going to talk about another project that we're undertaking together on wind generation development in Ireland. So the first study within this strand that I want to talk about is a study on people's willingness to pay for electric vehicles. And this is a survey-based study, and we've already conducted a pilot with 200 responses. And I guess as part of the pilot, we were refining the survey. We met with a lot of industry participants, particularly ESB e-cars. And we're now rolling out a national survey, so it's with the survey company at the moment, and they're collecting responses across the country. So what we wanted to ascertain with this survey is what do people value most about electric vehicles, and what do they value most in terms of the policies associated with electric vehicles. So some policies that have been put forward are things like the ability to drive in the bus lane, perhaps reduced parking charges, reduced tolls at toll roads if you're driving an electric vehicle. So it's the first study of its kind to value not only the characteristics of the electric vehicle, but also to put those alongside policy measures as well. So it's a stated preference survey, and what that means is that the survey respondents are presented with what's known as a choice set. They're presented with 3 vehicles, and they pick which one they would like based on the characteristics associated with that vehicle. So I just have an example of a choice set here. So the responder would be presented with 3 different vehicles, 2 electric vehicles and a conventionally fueled vehicle. and a number of different characteristics there. So how long the battery will last, how long it takes to charge the battery, and so on. And then some policy measures. So we can see them there: permission to drive in the bus lane, street parking policy, and the cost of driving on toll roads. And across the bottom then, the purchase price. So we present the respondents of the survey with about 10 of these choice sets, with the choices kind of mixed around within each set. And by presenting them with a number of different choice sets and looking at their chosen car within each one, we can put a value on each of those individual characteristics. So we have the results of the pilot in now, and as I said, the national survey is out at the moment. So from the pilot, the values that people most appreciate are firstly the driving range. So how far can you drive with your electric vehicle? And people are willing to pay an extra €23 for every extra kilometre that they could drive with their electric vehicle. The next thing that was most important was battery life, so how many years the battery lasts for. And they'd be willing to pay an extra €245 for every extra year that they could get out of their battery. And the next most important was battery charging time, so how quickly they could charge the battery in their electric vehicle. So they value that at €464 for every hour they save in charging their electric vehicle. And in fact, what was surprising was that some of the policy measures in the pilot were the least important characteristics. So people didn't seem to care that much about being able to get free parking or drive in the bus lanes. What was really important to them were the characteristics of the actual car themselves. Now, I guess it'll be interesting to see if that changes with the national survey, so we'll have to get back to you on that one. So very quickly, the second study that I wanted to highlight is just on it's a valuation of the disamenity from wind turbines. So essentially, a lot of the opposition, the local opposition to wind turbines, is associated with the visual impact and people's concerns, whether valid or not, about health concerns and so on. So those visual impacts and health concerns should be incorporated into the value of houses within the local area. So this particular study is looking at how wind turbines affect house prices in the local area. So it involves a GIS map of all wind turbines in Ireland, and then looking at a house price database from it. So this is in collaboration with daft.ie, so with Ronan Lyons, the economist from Daft. So looking at house sales over the last, I think we're going to look at 5 years, using the Daft database and the property price register, and looking at the impact of wind turbines on house prices. So what I'm going to do now is hand over to James to talk about the retail trial.
Right, thanks, Eleanor. The title of this paper is Increasing Efficient Appliance Purchases Through Lifetime Consumption Costs. The problem is the energy efficiency gap, and this relates to the apparent underinvestment in energy saving technologies. Specifically, if we look at the lifetime discounted energy savings of, say, electric cars, A-rated washing machines, solar panels, they seem to always outweigh the capital costs incurred. So in short, households, firms, businesses are missing out on valuable cost-saving investments, profitable investments. The aggregate effect of this is obvious. We have a stock of appliances that is consuming more energy than they should be, and overconsumption of electricity, more generation needed, higher CO2 emissions. That's based on very simple kind of net present value calculations, very simple cost-benefit analysis. To understand this energy efficiency gap, we probably need to look at it a bit more deeply. So there's a number of factors here. There's plenty of factors that might understand or explain the gap, but I'm only going to focus on 4 here now. Number one is imperfect information. Do households really understand the technologies available to them? Do they understand the energy savings associated with each? And probably more importantly, are they able to convert those energy savings into the monetary savings required to calculate, to make a profitable investment? Asymmetric information. Is there a trust issue? Do households believe the energy saving promises of retailers and manufacturers? If they don't, then they're going to discount the potential energy savings considerably. Uncertainty is at every level of an investment decision, and this is probably even more so when in the decision to buy an electric car or even an A-rated machine. What are energy prices going to be in the future? Do people know what their energy use is going to be? What is the resale value of this product going to be? Again, all of these are highly uncertain. Finally, inattention. Possibly that the problem goes a little bit deeper. It's possible that households don't even consider the auxiliary costs of the products and appliances they buy. The aggregate effect of these four things is that there's going to be heavy discounting of energy savings and possibly no net present value calculations. So an energy efficiency gap probably isn't all that surprising. So this is where our trial comes in. We hope that providing monetary lifetime consumption costs of appliances will help reduce these four issues: the uncertainty, the inattention. And we're going to carry out a trial in conjunction with a large Irish retailer and we're going to apply these labels to dryers, TVs and fridge freezers. So just give an example of what this looks like. Well, that's the current EU labelling for a dryer. We're just going to place our labels alongside this. Very simple, 10-year energy costs. Based on this machine, just in the bottom there, it says for this unit's energy rating, 1.9 kilowatts per cycle, 800 kgs of clothes per year, that's about 2 loads a week, and we're assuming no increases in electricity prices for the next 10 years. It's a randomised control trial, so we have the usual treatment groups and control groups. We're going to pick 4 stores randomly, apply the 10-year labels in a trial period, hopefully September to October this year. And then we have a benchmark period about 2 months before, and we also have a control group where there's going to be no change in labelling. The types of data we're going to get from this is obviously unit sales of each product, product characteristics we can get ourselves, price, efficiency level, product size, things like that. We can also look at store characteristics, maybe possibly if there's differences in income of the store locations, that type of thing. We're in the process of a preliminary trial at the moment, which involves adding 5-year consumption costs to dryers. And this is underway in 2 stores, and that started on the 1st of May. The methods, nothing fancy, very straightforward. The benefits of having a randomised control trial is you can really just compare means across control and treatment groups. So we'll be looking at the efficiency change in the treatment group, see if buying has become more efficient, and comparing that to the control group and see if there's any significance between control and treatment. This can be done econometrically through a difference in difference model, which means we can include a lot more kind of appliance-specific characteristics like price and size and things like that, and also some store characteristics. The outputs, well, obviously, if we do find a significant effect, then there's implications for how we label appliances in the EU. If there's no effect, then it's business as normal, carry on as it's going. So, thank you very much. Hopefully this time next year I'll have some solid results to present to you, and thanks.